Welcome to Graphing Logarithms and Exponential Functions. Here we're going to take a closer look at a couple of keywords that might be new for us. Exponentials, probably new, and logarithm. So here we're going to take a look at what do exponential functions look like. We've worked with exponents, but not really gotten a chance to truly see what these look like. You'll see that I've highlighted the 3. This is called the base, and it's usually the number that we are multiplying by. So because exponential functions have many bases, I can do 2, 3, 5. There are lots of parent functions. So I like to say, what is the base function? So if I take away the transformations, really I'm starting with something that looks like this. Y equals 3 to the x. So before I start graphing, what I like to do is pick a few points. So I'm going to create a little tiny table over here in my notes. So let's say I try to plug in a 0 in for x. Well, 3 to the 0 would give me 1. If I tried to plug in a 1, 3 to the first would give me 3. What would happen if I tried to plug in a negative 1? So 3 to the negative 1. That is a negative exponent, which will cause a flip. So 1 over 3 for all of my y values. And now I'm just going to sketch that really quickly. So here is something that your graph might start to look like. You'll see I also did 2 because 3 squared is 9. So I can see my exponential is really, really tall, growing very quickly. It's exponential, you could say. And then it starts to get really small. So with all of these negative x values, these negative exponents, they'll all kind of become very, very small fractions. So here is the good news. With exponential functions, they actually will have a horizontal asymptote. So right there is kind of where it's located. So what we are going to do is try to move this and transform it. The good thing is all of the rules for transformations that you have seen all year still work. So I see an x minus 1 in green. So that means I'm going to take this graph and shift it to the right by 1. A minus 2 on the outside is going to subtract 2 from the entire function, which shifts our graph down by 2. So I'm just going to take my graph. I'm going to shift all these points right 1 and then down 2. So right 1, down 2. That looks something like this in blue. So I'm going to label this one my f of x. So key points, what we mean by that are really this point and this point. Whenever we plugged in for 0 and we plugged in for 1, these are fantastic points for exponential functions because anytime you plug in 0 for the base, any exponent of 0 will go to 1. So 3 to the 0 was this one. But if it's 2 to the 0, 10 to the 0, it always goes to 1. The good thing is when we plugged in a 1, I ended up doing 3 to the first, and it got me back to 3. And 3 was the base. So that is going to be the other common point. So 1, comma, whatever the base is. So these were the key points that we shifted. So 2 are more than enough. Because I shifted the graph down 2, you'll see that I've got y is equal to negative 2. So here is that horizontal asymptote in light blue. So I can clearly see that this also shifted down 2. Domain, well, I can plug in negative exponents, positive exponents. I can plug in 0. So I have a lovely domain of all real numbers. Again, remember that domain works all the way to the left, all the way to the right. But for the range, bottom to top, I don't have any y values below here. It looks like they're all hovering around negative 2 and then going upwards and onwards. So the range is from negative 2 up to infinity and onward. And that is our very first function. Let's try one more. I threw a couple more transformations at us, but let's focus on the base function first. So where am I starting before all this extra stuff got thrown in? So here I see the base is 2. So my base function for this one is y to the 2x. For transformations, I've got lots of them. I see a negative on the exterior. So I'm going to flip on the x-axis. I see I'm multiplying that whole function by 2, which is really going to pull that graph up, and it's going to vertically stretch it by 2. And then at the very end, I'm adding 4. So that will shift my graph up by 4. I'm not moving left, and I'm really not going right. So the key points for the original base function, well, if I plug in 0, 2 to the 0 gives me 1, and 2 to the first gives me 2. And again, you'll see that I match the bases, so 2 and a 2. So I'm going to go ahead and sketch this graph, so 0, 1, 1 and 2. You could do 2 squared is 4. You could do 2 cubed is 8. And then again, you'll have a couple of the fractions, but not too terribly many, just enough to get a good, clear picture. So now I get to do some moving. Well, it says that I'm going to take this function, I'm going to flip it across the x-axis, vertically stretch it, and then move it up by 4. So all of these transformations are affecting the y values. I'm not shifting anything left, and I'm not shifting anything to the right. So my x's are going to stay the same at 0 and at 1. But the y values are now going to get moved around because I'm going to multiply by -2, and then I'm going to add 4. So I've got 1 times -2 is -2. -2 plus 4 is +2. And I can do the same thing with this coordinate. So 2 times -2 is -4. Plus 4 is 0. And here are my brand new points. I also can see I've gone up 4. So that is going to give us a new horizontal asymptote right here at 4. So I'm going to shift this up by 4. And then now I'm just going to finish the rest of my picture. So here's where it got flipped. And it's just going to get really, really close to there. So it looks something like that. Domain, hopefully we like, because I can pick any exponent in the world. You've got -infinity to infinity, bottom to top. Be very careful here on the range because I can see I have flipped and all of these y's are going down. So your range from -infinity below up to 4, which was that horizontal asymptote. So the a value, the one in front, we got a chance to see what happened when it was negative. So that's going to exterior flip on the x-axis. If a is larger than 1, it's going to stretch. So it's going to multiply all those y values. If it's a fraction in the front, I'm going to be dividing all of those y values, which is going to flatten, but we like to say compress. The b stands for the base. So this is the number that you're actually multiplying by. So when we say, what do we mean by that? So like 2 to the x, well, I have 2 to the first, that got me 2. If I did 2 squared, I would do 2 times 2, giving me 4. If I did 2 cubed, I would do 2 times 2 times 2, giving me 8. So you'll kind of see how I'm multiplying by 2 each and every time. So that is actually what the base is and kind of what it means. You also have your h value. So when it's positive, you go to the right. Now, when it's negative, it goes to the left. It just doesn't look negative. So I provided an extra example there. So normally when we see these, you'll actually see a plus sign. They always kind of get shrunk back together. If k is positive, you're going to shift that graph going up. And if it's negative, it will shift that graph down. So luckily, all those rules still apply. They're not brand new. Well, right now I can see I have an asymptote right here at 2. So that means I've shifted the graph up. So that can help me with my k value. Now for the y-intercept, this will be nice because I have a coordinate. And so what we are going to do is try to plug in, because if I have a coordinate wherever I see a y and wherever I see an x, why don't we just plug in? I'm going to go ahead and leave off the stretch for now because I'm going to try to make a very straightforward graph. So I'm going to plug in a 0 for x. I see minus, I don't know left and the right, but I know it went up 2 because of my horizontal asymptote. So let's do a little bit of solving. I'm going to subtract the 2. So we have a 3 on both sides. So why don't we go ahead and make this easy on ourselves? So if this is going to be equal to 3, why don't we make the base equal to 3 just to keep it nice and easy? Because maybe I can make this a 3 to the first and make these two match. So I've got 0 minus a number is going to give me 1. So that means I've shifted the graph left. So my final answer when I finally want to write it out is I'm going to have a base of 3. I'm going to shift it because h was negative, and then I've got up by 2. Just be sure for that final answer, you go ahead and make that a plus. So this graph happened to shift left 1 and up 2. So you can see on this quick pit stop, I have a 0, 1 and a 1 base. And oh, what did I do? Well, it looks like I took this coordinate and I switched my x and y's. And I did the same thing here. So I did 1 comma the base. So this was 1, 2 in the red. And I made it 2, 1. And I switched them. These kind of look like mirror pictures. They're almost like one another, just slightly different. It's like if I drew this line, I could see a nice reflection. Hopefully the word inverses comes to your mind. So yes, the blue graph is an inverse for our exponential. And these are called logarithms. They undo exponentials. We've seen inverses before. So think of something like x squared and square root of x. Those functions undo each other. X cubed and cube root undo each other. So on here, this one happens to be 2 to the x, and this one is a logarithm. And the way we write that is log base 2 of x. And those functions will undo each other. And you'll see they've swapped coordinates. So now I have new key points that I get to graph. Here's the good news with these. You also have the same rules for transformations. A is still going to be your vertical stretch, compression, and flip. You still have the option to shift left and right, and you still have the option to add up and down. So on our exponentials, we had a very nice horizontal asymptote at y equals our number. But if we're switching x and y, instead of a horizontal asymptote, we now have a vertical asymptote. So everything is switching. So lots of stuff is going to switch. You'll see I still have the word base function there because we can still use that to guide us. This one happens to have a base of 3. And you're like, how am I supposed to graph log base 3 of x? Luckily, we are really good at switching x and y. So here's the good news. We are very comfortable with exponentials. These are a whole lot easier. So normally I would plug in 3 to the 0 and get 1. I would plug in 3 to the first and get 3. But since I'm working with the inverse, we're going to make it 1, 0 and 3, 1. And we can graph all of those points. You can even graph a few more. So if you know 3 squared gives you 9, you can even plot that one on here as well. So it almost looks like that last graph that we had. And if you would like to go ahead and sketch that vertical asymptote just so you can get a clear picture, you can. Let's identify some transformations. So on here, I see a 3 on the inside next to the x, so that's going to shift this right. I see a +1 on the outside, and that will shift this up 1. So I'm going to take all of these points that we just found and shift them. So I'm going to go right 3, 1, 2, 3, up 1, right, 1, 2, 3, up 1, and this one's probably going to fall off the graph. Because I did shift it right by 3, I'm going to have a new vertical asymptote right here at x is equal to 3. So there's the same color, right? 3. So it's going to look something kind of like that in green for a final picture. Now the domain looks restricted because it looks like I'm getting close to 3, but I'm still increasing. So your domain is now 3 to infinity. I'm a little bit more restricted, but the range bottom to top looks like I'm still going down, and eventually this will keep growing. So your range is now going to be all real numbers. First, let's find the base function. I see log base 2, so that will be where I'm going to begin on this graph. If you are comfortable and you would like to work with an exponential and flip them, you can, or you can just use those key points we had before and flip them as well. So I've got 2 to the 0 gives me 1. 2 to the first gives me 2. So when I have those key points, I'm going to have 1, 0, because they're inverses, and 2, 1. Let's discuss transformations. I've got quite a few going on. So let's start left to right. I see a negative on the exterior. So all those y values are going to flip, so causing an x-axis change. This one's a little tricky because it looks like a +1, but be very careful. It does move left because of that pesky double minus. And the last one, the -5 at the very end, will shift this graph down 5. Well, since I am shifting everything left 1, my vertical will now be at -1. So here what I'm going to do is take these points and I'm going to flip them on the x-axis. Then I'm going to shift it left 1 and then down 5. 1, 2, 3, 4, 5. So there's my new point. I'm going to do the same thing here. Flip it first. It's kind of like reading English, left to right. You do the transformations left to right. So flip on the x-axis first, shift it left 1, and then move it down 5. 1, 2, 3, 4, and 5. Here's this one. Just need to be sure to graph that new vertical asymptote right here at -1. So I know there's my boundaries. And then we're just going to go ahead and draw our sketch. All right, domain looks like I'm still being limited. So I'm going to be really, really close to -1, but keep going toward infinity. Range, bottom to top, this is going to keep stretching further down the y values. This will continue stretching up on all the y values. So I'm going to have an all real number situation.